I saw an interesting video last night. Of course, Dean knows I watch videos all the time, but the thing is that there is a interesting, and I have to do some research on this. It might be worth a discussion with the futurists about stakeholder economics instead of shareholder economics.
Oh yeah, no, I know all about that. Yeah, and it
And
has worked, and it can work.
stakeholder basically it includes customers and supply chains and more of the environment around the corporation as
Yep.
part of the corporation to essentially create a wider tent or a broader tent around the
Yeah.
health of the organization.
No,
Uh,
I mean, yeah, but that culture exists. You know, when I was installing Amazon sorting machines around the country, um, I mean, they didn't just play lip service to team. The different contractors and whatnot. They were a team because they all knew that their income stream depended on being a good team member, just like a basketball team or anything else. And they were pretty much. I mean, there were fights, of course, but yeah, they realized that yeah, if we work separately for our own greed, or we're all fail, and if we work and compromise and everything else, I mean, big companies like Honeywell, they had to bite the bullet if they wanted to sell those products.
Or do you know anything about AWS?
But what?
AWS, Amazon Web Services.
I know that I despise the guy that owns it, but yeah, go ahead.
Well, he might be a stakeholder in your world.
Oh, I loved his lip service. They made a big deal on the news. Amazon has a Christmas time, holiday time, a tip your driver program, right? And and you can blah blah blah, and you get something for it. So you get a delivery, and then when you're rating it or whatever, there's a thing: tip my driver $5. Well, the first 1,000 people that do that, they have what, 4 or 5 million deliverers, and so 1/10, 1/100th of 1% of them get a $5 tip. Whoop-de-doo. It's all PR. Burr, yeah, oh, that's downtown, inland. Burr, yeah, we're going to be in the. We're not gonna hit the 70s this week. Burr.
we're going to get some freezing rain, I think, today.
Oh God, that's the worst.
Predicting slippery sidewalks and streets.
Yep. And I think about Karen out there walking on the ice and snow. Um, I think she had a fall or a near fall or something. As we get older, falls are less friendly.
Yes, yes.
And
Yeah,
I'm
I've
used,
gone through some of them, and they're
yeah,
hard.
yep.
Go
Some
ahead,
of us
Lyle.
bounce less well than we used to.
So is Doug Shoemaker related to Willie Shoemaker, the amazing jockey? I shook his hand. Yeah, I used to go to the races here in Delmar, and Willie Shoemaker was a legend.
I used to claim him as an uncle, but unfortunately he wasn't.
Yeah. Yeah, me too. Well, I claim Tom Petty and Richard Petty, but I'm still waiting for my check. Yeah.
The videos.
By the way, I was just this is a total aside. I was just thinking about deportation and legal versus not so legal immigration and all that, and I realized, wait a minute, the Pettys came 2 years before the Mayflower, 1618. Well, there was no ICE, checking you at the border. There was no border. You got on a boat and you made it over, and there you were. So in a sense, were we illegal? Well, to the Native Americans, we sure as heck were illegal.
Yep.
and deadly.
It's so funny how history doesn't play into politics very well.
Oh, they don't teach history. My God, I watched a Jeopardy. It was a good Jeopardy. American history might as well be astrophysics. They don't teach it in high school. It's not politically correct. Oh, they were all slave owners, so we won't even talk about them because it makes people uncomfortable or who knows what. They don't know anything about American history. They don't know who Thomas Paine is, early revolutionary history. They don't, unbelievable.
Mm.
And geography. And if you have no sense of geography, don't play the game of Risk. Remember the game of Risk where you,
Oh, yeah,
you
that was
better
fun.
know geography.
I
Yep,
think
I
that
agree.
I think one of the things I was interested in, and this is about teaching students that are below high school or high school below, is that when you're teaching students that are still in quotes in the home, parented by their parents, as an instructor, you have to be sensitive to what kinds of information that they get, and it has to be very politically correct stuff.
Oh yeah, it's all PC. Yeah, and I mean, there were things. Even when I was a kid in elementary, there were, my dad was president of the PTA, and they'd get irate parents, and yeah, yeah, and there's always a little bit of a tightrope, but that's
Mhm.
what education is supposed to be.
Yep, you can't even say a pledge of allegiance these days.
Well, really see. I refused, and I was in I think third grade, fourth grade when they added the under God. And I asked my parents and my grandparents, because we're like seventh generation atheists. And I said, so what do I do? That makes me feel uncomfortable. And they discussed it in class. They said, okay, we have a new Pledge of Allegiance to say. It contains the word, because of Eisenhower and the anti-commies thing, contains the word under God. If you feel uncomfortable saying that, just say nothing.
Exactly.
Or you could choose to leave the room during the Pledge of Allegiance. I don't know, nobody did. I just, I just mumbled under Darwin, and that was it. Yep.
It's kind of like when I was. It's different for me, Dean, because I'm, I when
It's very different for you, Stan. Yeah.
it's like keeping your eyes open during prayer in church.
Oh yeah.
You're not supposed to do that, but I found myself interested in doing that, so I would take a peek now and then.
Oh yeah. Look around the room, right? Exactly. Yeah.
And I also found it interesting when you hear people pray in a crowded room. It was obvious that they were saying things on the crowd level that they wouldn't say in a smaller group level or maybe even with one other person. So it's just an interesting version of conversation, I think.
Yep.
Does anybody have any random bits this morning?
Any random what? I'm sorry, I missed that. My ears aren't good today.
Things that we think might affect the future that other people may not be aware of,
Oh,
particularly anything new and different this week.
oh. Well, how about the nominations for the cabinet and the, yeah,
Um,
they're new and different.
yes, and likely to affect the future, but
Oh, yeah.
unfortunately, we try to stay away from politics as
Oh,
much
absolutely.
as
No,
possible.
I just, at this point, I can only just enjoy it and have fun with it and mock it and whatever. That's all I can do. I'm just
Yep.
along for the ride.
Aren't we all?
Yeah.
The
Well, we
question I keep wondering is, how did the Democrats stay home from the polls in such large numbers?
Well, because apparently they don't mind being bused to another state to get health care when they get pregnant and whatever. I don't know. You know, because I'll tell you why. Because young women have their face completely buried in TikTok, completely. And yeah, oh yeah, I'm going to vote. I'm going to vote. No, they don't because they're doing this. Oh, gee, I forgot to vote. If you could vote on TikTok, and somebody suggested that years ago, why not be able to vote with Face ID, et cetera, on your phone? Millions and millions of people would vote that don't vote today
Yep.
on both sides.
But it's difficult enough to register voters now and see that people who are not registered do not vote.
Right. Oh yeah, it's wait no, and because all cell phones
using cell phones would just
because all cell phones are hacked by definition.
Yeah.
And so yeah, no, it opens a whole big ball of worms. You don't want voting on the internet. No.
And even the ballot counting machines that we have now potentially,
yeah,
if they're hacked, nobody's going to know.
Yeah, the ones we use in San Diego now are never, ever. It would take somebody walking in with a thumb drive to do it. There is no connection to the upper network whatsoever. Once they have the software downloaded and verified and all that, they pull the plug.
But the question about hacking the software before it gets downloaded.
Oh yeah. Well, there is that.
Is still a can of worms.
Yeah. Well, worm is a good term because they build in worms to the software. You know that. Yeah.
Yeah.
Time bomb worms or whatever. Yeah. Oh, there's just myriad ways to do it.
So much of the world does not know how to program or how to read code.
Oh yeah.
And if you allow the company that manufactures the vote counters to keep the code proprietary that controls the vote counter.
Do you think that do you think it's fair to assume that there might have been some foul play with the voting in this last election?
We know that about 90% of the seats in Congress at the federal level are safe, which is to say they elect either Republicans or Democrats on a repeated basis better than 75% of the time.
Yep, and people vote along party lines, you know, and there's some in the middle.
What that means is that there's only 10% of the districts in the country that are voting for senators or representatives at the federal level that determine the election.
And we have Mr. Mander to thank for that. Jerry Mander, you remember him? Yeah,
something like that. Yeah.
I have a question. It seems plainly obvious to me, and it should be a matter of common sense if you use scientific reasoning and rationalization. We use the same metrics. We use the same standard metrics for safety on board airplane flights, safety with driving, safety with the post office, safety with basically every other facet of life in which we need safety and security. We use identification to maintain the integrity and safety of a system in all other facets of life. Anyone who claims that they care about the integrity or the safety of an election, but then counter-logically says that they're not in favor of using basic identification to maintain that safety and integrity, is not really approaching it from a scientific or rational process.
Jason, that experiment has been done so many times in this country. Have you looked at the results?
But
who can carry
do we
a driver's license?
You got to use it for every other system, whether it's driving or airplane flights or anything, getting a job.
Let's look at airplane flights. Thank you for bringing that up. How long has it been that they've been talking about changing the identification for airplane flights? They've put in a new system, and they've delayed it now at least 2 years that I'm aware of. And thank you for raising your hand, Dean. You're on. But you're also muted.
Unmute. Okay, yeah. Real ID. It was supposed to go in what, 4, 5, 10 years ago, and they're still fumbling around with that,
Yep.
because it involves a national ID, national driver's license, and all that rigmarole. But how about that woman that went through the crew line at TSA? I mean, TSA is the most inept organization on the planet. 90% of all loaded weapons smuggled by the FBI get on planes. And, they just get, oh, no, you shouldn't do that. There's a letter of warning. And really? Yeah.
TSA, the American Gestapo.
Regarding real ID, if I may, my wife can't get real ID because she doesn't have a marriage license that proves her name. And so they bounced her around, and the only place she can get it is from Jamaica, which is a hopeless case. So she doesn't get real ID.
I was going to mention that this is kind of a different track here. I saw for the first time, I guess I didn't really know much about this person, but there's a Sheldon Whitehouse from the Democratic senator from Rhode Island. And I recently saw a really interesting video where he's describing the pathology of Americans' response to climate change, beginning with ignoring scientists and then denying the consequences. And now we're in the third level, which is basically we're living through the consequences. And what he specifically points out is that because of the Frankenstein-like weather conditions that we're having, especially give an example of Florida, for example, where there's been very, very limited amount of ability for the insurance companies to respond to the high level of demand for rebuilding after disastrous weather storms and so forth. That we're really in the level of consequences, paying for our neglect of the planet and the environment, and it's going to hit us in the pocketbook big time. But if you ever get a chance to watch him and listen to his discussion, it's very. His wife is a scientist, and he's very knowledgeable. I think a very interesting character. Sheldon Whitehouse.
So, in the two options, and people who have the audacity to say that there hasn't been a number of high-profile voter fraud cases across the United States, I will post the links once again across the board of a number of states where it was proven that there was widespread voting fraud. What is the better of the two options? One, we prevent what is the better of the two options? One, we require ID for elections, and a few Americans who don't get their ID are unable to vote, or two, we keep the status quo and we have people who are not eligible to vote in this nation vote, and therefore we have election interference by non-state actors on a massive scale.
We have a massive scale of election interference by state actors.
But what is the bigger danger? Excluding a few Americans from voting, or allowing non-Americans to vote?
Jason, if we were a third world country,
Nobody answered the question. Which is the bigger danger?
Neither one is acceptable.
Well, exactly. So this is a straw man argument for not wanting voter ID. Or you need an ID to do anything in this nation. It should not be controversial to require ID at the voting booths. You need it to check out a library book, for God's sakes. You need a driver's license to get a library card. You need a driver's license to darn near take a piss in this nation. But yet, when it comes to voting, one of the greatest privileges and rights of a citizen, you don't
make up your mind. Is it a privilege or a right?
Voting is, I believe it's a privilege, because felons cannot vote.
Yes, they
Criminals.
In some states, it's up to the states, and that's part of the problem.
Anything
What happened when the Supreme Court struck down part of the voting?
Anything that could be
Voting Rights Act is what it was called.
Anything that could be revoked or taken away is a privilege, not an inalienable right. Otherwise, it wouldn't be allowed to be taken away.
Well, if it's inalienable, then it can't be taken away. There are few things that are inalienable, including life.
Seems to me it would be a right as long as you're taxed. There's no taxation without representation.
Another story that we've told in grade school. Essentially, we have a very poor voting system, and it's been documented.
Mm-hmm.
Lino.
I'm of a mind that all of these things should be at the state level, that we should not be relying on the federal government for anything, because it's going to be subject to massive hidden stuff. And if it's a state right, then I think that it can vary, and it's okay. So that's my opinion on states' rights.
Dean?
Yeah, so I just came back in the room and heard poor voting system. The poorest turnout among first, second, and many third world nations. And where is it? New Zealand, where voting is mandatory. And if you don't, you can be fined. It's just like your DMV fees aren't optional, they're mandatory. Yeah. Taking the driver's test is mandatory, and so is voting. I believe it's New Zealand.
Interesting.
Tom, how do you want to do your videos?
I'm going to try to show them myself.
Okay, good.
If that doesn't work, then I'll have to ask Stan to.
May I make
there's
a suggestion?
There's only two.
Okay.
Don't try to.
Regardless if you
Try
show them or I
to
show
show
them.
them from within a PowerPoint. Show them from outside of PowerPoint.
I'm not using PowerPoint.
Oh, great.
Tom, whether you show them or I show them, please send them to me so I can do the video.
They're posted on the meetup site.
Oh, okay.
There's links on the meetup site.
Thank you.
From a rational, logical point of view, the only conclusion I could figure, the only rational argument that makes sense to me to argue for not having voter ID is that one party thinks it will confer a political advantage favorable to their party by not requiring voter ID. And I don't seem to be the only one here who thinks that makes sense. Because from a logical, rational perspective, that seems to be the only plausible reason why you would make such an argument, is that you think it would confer a political advantage to your party in terms of overall vote count, which,
Of
you
course,
know,
if the
that's
government,
that's the height of hypocrisy if you're claiming that you care about election integrity and true. I mean, if you care about, yeah.
if you claim to have universal suffrage, which we do, bounded by age and felon status in some places, then voter ID is only necessary to prevent some bad doer from voting more than once. Big purple marker on your left hand or your right paw would suffice. Dip your thumb in the ink after you've cast your ballot, before you leave the polling place. You can't go off then and vote somewhere else or vote again here. Voter IDs are merely a way of controlling who can vote. If you don't have your ID, you can't vote. Well, your ID has been issued, but you haven't gotten it yet. I have a friend who has a letter that's coming 150 miles, and it happens that it's being traced for various reasons, and it's taken so far 18 days to get 150 miles.
Oh,
Yeah.
I agree.
The post office is not the most reliable feature of our country.
Tom, your hand is raised.
Can't drive.
Yeah, I came a little late to the conversation, but you were talking about states' rights. Basically, it seems like the current Supreme Court has enshrined states' rights as paramount over federal. But the way I see it is they do that ideologically for topics that they have a particular bent toward. If there's a case where the federal government will overrule the rights that agrees with their ideology, they'll side on the side of federal power.
Carol?
Yes, I would suggest to Lino and other people who are gaga on states' rights that we are a country. We are not a conglomeration of states. And rights
That's debatable.
Rights that apply.
Read the Constitution.
I'm about to quote it. Rights that apply to all people in that country need to be enshrined in the Constitution and apply to all people in the country. Rights that apply only within a particular state need to be enshrined in the state constitution.
Those that devolve from the federal to the state, and if they devolve from the state to the individual citizens. I think that's the way the Constitution is written. Sorry for the interrupt.
All rights not enumerated in the Constitution refer to the states or to the people.
Yes.
And here's the question.
Excuse me. I think this discussion would go on for 2 hours without any question. And,
eight hours.
yeah,
Terry, you were up next.
Terry, and then we
We're
need
getting
to get
close
to
to the
Tom.
meeting.
It is 10 o'clock.
Yep.
Oh, I was just gonna say that yeah, the Constitution sets the floor as far as standards. States can raise the bar above, but they can't fall below. And then the powers not delegated to the federal government are reserved to the states. I mean, it's pretty
Or to the
non-controversial.
people.
Well, sure,
Mhm.
sure.
Well, that's what it says.
That's what it says.
Absolutely, absolutely. But the people is not the federal government. I think we can
No.
agree to that.
There's a
So-
degree of vagueness there because you
Jason,
can't account for every.
Jason, you're out of order, please. Tom, we promised you to start at 10. It's still 10. You're on.
Okay. Discussion to be continued later.
Yes, please.
Maybe a presentation for later.
It's been done before and will be done again.
How many of you use your GPS? You pick up your phone, you want a map to the Park Theater, you want
Yeah.
this. Yeah. Everybody uses it. What happens when it breaks? There are lots of ways this can happen. The satellites can get out of sync. They can be not updated properly. Enemy action can take them out of orbit. People can put up interfering signals. It can be a petty problem. You get to the theater 3 minutes late. But it can be spoofed. People can take local transmitters and pretend to be a GPS satellite. And knowing that your ship is traveling here at this rate of speed, they can alter your what the ship's GPS receiver thinks of as your position. This has actually been done, both to little boats and to military ships. This created large amounts of panic. Why am I driving onto a rock? Well, that one was pirates who captured a yacht. It's a problem. And to solve the problem, the Russians put up their system, and you could use both. So if one of them is being spoofed, the other one won't be. Oh, but yeah, that doesn't work very well because they can both be spoofed. The Chinese came along and added a system, and so now you have 3 you can spoof. And they can all go down. Giant solar flare, any number of celestial things that do not involve science fiction attacks, just whatever.
How do you want to handle questions, Tom?
Carol?
I would suggest a major solar plasma burst, like the historically documented Carrington event, would take out the functionality of all satellites and most of civilization.
Dean? Yeah, Carol, you're right.
Not just satellites, but the power grid, et cetera, et cetera, et cetera.
That's what I said.
No,
Most of civilization.
it would take out both. We don't need to have an argument about that. Our society is not built to withstand a Carrington event. It is just absolutely not built for that. Jason?
I have a question. If a satellite is on our side of the planet, the dark side of the planet, when the solar flare happens,
Yes.
would the satellites in transit on the far side of the planet be affected? Or
Yes,
Yes.
okay.
because the plasma event directs electrical fields down to the poles.
You're
You get aurora down to the equator.
you're thinking that there's a shadow that's going to protect the satellite.
Not.
No, I agree. I'm talking, Jason is thinking there's a shadow behind the Earth.
What
That will
happens? It does
protect
not
the
just
saddle.
slam into the equator. It directs all this electrical shit down at the pole.
It doesn't work that way, Jason.
Yeah.
They're all gone.
I think it wraps around the Earth.
Mm-hmm. Yeah.
Like the magnetic field.
Yep. The magnetic field is another thing. When I was a kid, the declination of the North Pole varied from the East Coast to the West Coast by 3 degrees. For lots of purposes, you could ignore it unless you were flying. Now it's, how far is the North Pole now? 700 miles from the geographic pole, and moving further and faster every day. Paper and compass might not be as useful as you think it is. But there is a way to keep track of where you are. If you have a box, we're going to call it a magic box. Here. Magic box. Has a special substance in it that knows when it's moved. So when I move the dish from here to there, the dish knows that, and it can tell me. I was over there, now I'm here. This is called inertial reference. And it works. And it's been around in theory for centuries, I suppose. Some of the old fables of the magic stones that knew where home was. It's becoming a real thing. It's called inertial reference. Modern airliners use it. Modern ships use it. Airplane tells the box, you're here. And then the airplane takes off and flies away. And the box keeps track of the motions of the airplane. Up, down, left, right, sideways. And then
orientation too, Tom?
Orientation too. Okay. And then later you can ask the box, where am I? And assuming you haven't crashed, the box will tell you rather reliably, within 10 feet, maybe, for a commercial airline around the world. It's a big thing. I mean, it's the size of a trunk. They're getting smaller. They're getting lots smaller. In a decade, you'll be able to wear one on your wrist. Yes, Dean. You're muted.
When I fell in the tub, my watch said, "Oh, I see you've fallen. Do you want me to call your brother or 911?" I said, "Call my brother."
Mm-hmm. Carol.
How about if we call on people in the order when they raise their hand? I was first.
Yes, you were. Yes, Chris.
What about acceleration and constant motion? The bull can definitely tell it's moving when it's accelerating, but inertia, as far as I understand, is only affected when something is accelerating. When it is moving in a constant
but everything. Okay. This is the bull sitting here. Yeah, lands there. The bull, you say, is not moving.
If
so
you
there's
have
no but let me finish. But the bull is moving. The earth is rotating. The earth is revolving around the sun. The bull is moving.
But we want to know where we are within a reference frame.
Yeah.
And that reference frame for all, like for an airplane flight, is a non-moving reference frame. When the airplane accelerates, you're going to know that it moves. Then if the airplane flies at a constant velocity for 3,000 miles, that bull doesn't know that this is. So what do you think about that? Is my reasoning correct?
No. The airplane sitting on the runway is moving. The runway is moving, and so the airplane is moving.
Is that Is that an Earth reference or a solar reference?
That's a universe reference.
It's an inertial system.
Anyway,
changes in inertia.
We think things are stationary because we do not observe them to be moving. Because the world we see, the bowl, my mug, the screen, the harmonica, those things are locally stationary. They are not moving relative to each other.
Right.
But the earth is rotating.
Many years ago, Galileo had a thought experiment where he was in a room in a ship and couldn't see anything, and he was moving at constant velocity, and he dropped an object and it fell straight down. It didn't matter that the ship was moving because he was inside and he couldn't see, and if he held a glass of water, the level of the water would be constant. So I must be missing something.
You're missing the idea that something you have accepted the delusion that there is something that's not in motion. Everything is moving all the time. But sometimes things move together.
And therefore they are in the same inertial frame of reference.
Yes. Sometimes they move independently. It's hard to accept. It's kind of like magnetism the first time I ran into it. There's something that comes along and goes right through me and moves that compass. I'll pick up. It's penetrating me. I can't hide it from the magnet. This is the same kind of thing. The thing is here, and now it's moved. And the magic thing can determine not only that it did move, but how far and in which direction and how fast. And if you add up all those things, you can control an airplane. Okay, Carol?
Yes, before you mentioned the wrist unit, I was going to ask you if your magic box was based on gyroscopes.
The current magic boxes are based on the idea of gyroscopes.
Okay.
The spinning, however, is not of a gyroscope, but of an atom.
Okay, this is not the same kind of spin that we describe on electrons.
That's a yes and no. It's the same kind. No, it's not. It's a different kind. Anyway.
It is an inertial spin.
It's this is inertia. This is called inertial tracking. And yes, we first used real gyroscopes, like the toy ones you spin and you try and tip over. And then they got more sophisticated, and then they got more sophisticated, and then they said this thing has moving parts. And they made gyroscopes out of lasers. And you could determine how things were altering because of the change in the spin of the laser. And now we've gotten to the point where we're saying that's big and clumsy and not accurate. And so we are just going to spin a nucleus. And
how is the spin imparted?
That's the video.
Oh, okay.
I'm not sure I understand it. But these people do seem to understand it, and they have, I think, good. The first one is a simple explanation. The second one is a complicated explanation.
Ooh, let's see these videos.
Okay, David.
I was just going to say that anytime you have gravity involved, you have an acceleration.
Yep.
And so it gets pretty complicated pretty quickly, because your example of things that were stationary relative to each other is really what we care about. We care about stationary relative to my home on the Earth. But the Earth is an accelerated frame of reference because of gravity. Einstein's special theory of relativity was all about special cases of accelerated frames of reference and not being able to tell an accelerated frame of reference from an inertial frame of reference. But because we live on Earth, the examples we can think of where we're talking about a frame of reference that is not accelerated are all within the last 100 years, where we've gotten away from the Earth, but not very far. And as long as you're in the solar system, you're in an accelerated frame of reference. It gets very complicated very fast because we want to know where we are in that accelerated frame of reference.
Leaving the Earth only adds tiny bits to the exponents, because just because you're off the Earth, you are still in the sun's gravitational field. And if you move way, way, way the hell out past the heliopause, or whatever it's called out there, far beyond Pluto, you're still in the sun's frame of reference. And if you keep going, let's pick on Alpha Centauri Proxima. Before you get there, you're going to be in two fields. One the sun's, one of Alpha Centauri Proxima. No matter where you go, you are accelerating. You may be locally stationary to your ship, to the Earth, to my basement. But all of that is accelerating. And so you too are accelerating. And what we're going to do for this new navigation box, this magic box, okay, magic box knows where it is. And when it moves, it knows it moved. Because it's not where it was. It can remember where it was, and this is not there. Ergo, I moved. And as he flies around and ends up at NSP and onto my desk again. First video. Okay, I'm sorry. We should have questions. Stan?
About 10 years ago, I picked up a motion performance system for animator, character animation. It was down, those used to be a flock of birds back in the day when animators started using motion performance hardware. Was about $150,000 for a single person unit. They came down in price until the one that we bought was $1,500, and it had these little, about the size of a nickel. You would wear Velcro around your wrist, and you'd have one on your wrist and on your elbow and your shoulder, and then you have a transmitter on your with a router on your back of your belt, and that would go to the router or the router on your computer. And these would send out both position and rotation information. They were called accelerometers. And you could use that to connect to your character in a 3D animation software. And instead of having to create this animation with sweaty faces like Pixar people do, you just record it. And it's called motion capture. Now, I'm assuming we were pretty amazed and stunned by that technology, but I'm assuming that this design of accelerometer isn't concerned about the rotation of the Earth and about the position of the sun in the Milky Way. So I guess what I'm trying to get my hands on is where does the attenuation of your devices stop being interested and then start being interested in what it's doing and where it's at?
I suppose the answer is that they're not interested. They just know where they are. And they're getting smaller. The motion, I suspect yours was more sophisticated than the one I wore for a brief period. It was about the size of my, come here, camera. It was about the size of my watch for one cent is what it was telling. And what it did was it recorded, or it received signals from a transmitter and sent off signals saying where it was.
Oh, like lights,
Yeah.
kind of like yeah. There's those too.
Yeah.
Um,
but in this case, the signal that's being received in that radio, it's in some ways it's gravity, but it's not real. I shouldn't say that. It's
Is it possible any of these questions would be answered by your videos?
Some of them will be answered by the first video and some by the second, and some of them are. There's an 8-hour session that I tried to watch, but it rapidly got beyond me. Lino?
I'm curious if it has to do with mass, speed of light, things like that.
Yep.
And I would ask Tom Walsh if he wishes to pick up on the physics of it, because I think it's way over my head. But I think it has to do with that, with everything inside of matter. So anyway, if Tom wants to pick it up, I'd hand it over to him.
You're it.
Well, that wasn't my question. Let me hit my question first. Could this system, this inertial system, be disrupted by earthquakes? Or can they ride through it and still keep track of where they are?
They could, I mean, they'd have to. They would notice the earthquake. They would report the motion that they felt from the earthquake.
Okay.
This is a funny subject. It really is.
Yeah.
The idea that the box, I'm here. You moved me. You moved me again. You're tipping me. And I'm looking at it saying, you're right where you always are, but you moved me. Because I am moving it very slightly. They will really, we are going to talk, they are going to talk about things that are measuring quantums.
Okay.
So big gyroscope spinning, laser spinning. Oh no, look how big the laser is. We need something smaller. We'll spin an electron.
So that brings me to this my second part of my question. These inertial systems that measure change acceleration.
Location.
Well, yeah, but relative to where they started or relative to some location.
Yeah.
Because they measure the acceleration or the change in inertia. Are they basically measuring the inertia with respect to Earth? Or does that also include the moon and the sun and whatever else? Jupiter.
My understanding is that they are not that sensitive yet. Although there's no reason they couldn't be. the effects of Jupiter's gravity on an object of any sort on Earth is going to be minute.
Right. So that leads to my question. If we're just navigating on Earth to figure out, the way to the grocery store and back or something,
Yeah.
we don't want those other influences affecting our calculations.
Probably not.
Because, we already moved 1,000 miles around the sun in the last minute.
Yeah. There's a level of detail that's available that you ignore.
Okay.
What the ultimate resolution is, no one's talked about. I suspect that might be the third video that I gave up on after 20 minutes because it was way over my head.
Do you have a reference for the third video so that those of us with some physics might try it?
I think all three are on
the meetup.
I'll give it to David and he can add it to the meetup description.
Thank you.
Separate from the other three?
Oh, did I?
There are 3 on there.
No, then it might be on there then. I thought there were only 2.
Nope.
Okay, Carrie?
Yeah, I'll keep this short. So my understanding of this is acceleration of gravity is different than acceleration. So as long as you're in a free fall,
they're accelerations.
If you're in a free fall, you are not experiencing acceleration. That's why you feel weightless. Right? Yeah, we experience the
your experience is deceptive.
I beg to
everything is always accelerating.
You are experiencing motion relative to other things.
Experience.
All right, if I'm on the surface of the planet Earth, I experience 1g acceleration.
Yep.
Correct.
Yeah.
Okay.
You experience a number of other accelerations as well, but that's so large it overwhelms them.
My body is being moved relative to other things. That's different than acceleration.
No, it's not.
No.
So if I'm in the elevator and I'm falling, how do I know what am I experiencing in terms of acceleration that I can move or that I can detect? There isn't anything. I'm floating. I am weightless. And I'm weightless because there is no acceleration. Weight is a function of being accelerated, right? That's different than mass. But
Having
anyway,
fallen in an elevator, I'm not understanding this.
You're isolated. It's the same thing as being in a free fall. Anyway, all right.
You're in a box.
Yeah.
You're in a box. Okay.
So inertial, navigation systems. I mean, these things have been available on commercial airliners since the 707.
Yeah, before that. They're available in World War II.
Gyroscopes.
Well, I'm talking about commercial aircraft. I mean, that was like the first one that had things. So it's not like it's magic. And we've got them in our head, actually. We've got an inertial navigation system. Right?
In a way, yeah.
Yeah. It just doesn't work very well. We constantly have to reset it with our eyes to the horizon and to our environment. Yeah. So if you try to fly in clouds, you will quickly end up falling. Because when you're in a constant speed turn, all of the fluids in your ear reach because of friction, reach homeostasis, right? And then you detect that you are no longer in a turn. And then when you roll out, you sense that you're turning in the opposite direction. But this gets back to the idea of accelerate. But I mean, if there's a debate, I don't want to, hijack the whole conversation. But I'm pretty sure that if you are weightless, you are not experiencing acceleration.
Correct.
In a way, yes.
But you are.
But
no, you are not. This is Einstein's relativity.
No.
If you are if I'm in the ISIS and I'm just floating there, I am still accelerating. I am not sensing.
You can't be
The
accelerated without sensing acceleration. You're moving relative to something else. That's different.
The station is moving relative to the Earth.
Correct, but you're in a free fall, hence you are at the speed of acceleration. When you fall at the rate of gravity, you become weightless. This is not acceleration. Anyway, we can go on and on.
This is the problem. This is the problem of trying to use words for mathematics. Dean, then Lino, and then videos.
Yeah, I had
Look at the video, which will answer these questions, I hope.
Excuse me, Carol. I had a bad pun. This GPS stuff is way over my head, but I've done hundreds and hundreds of hours of scuba diving. Well, you have the sensation of weightlessness. You are not weightless, but you do have that has to do with the buoyancy of the water, et cetera, et cetera. So
that's different. That's a simulation of it.
When you said, Carrie, when you said experience, your experience is what you feel, how it feels to you. But anyway,
one thought experiment. If you had a planet the same size as Earth,
okay,
positioned, and you're in between them, I presume you would say that you are being accelerated in opposite directions equally.
No, I would say I was being squashed.
No, there's a space in between them. They're being held by the giant hands of God.
Huh.
There's a point there where the net acceleration is 0. This is the same thing that happens in a free fall.
Well, there's the vomit.
Anyway, leave it there.
There's the vomit comet and there's the ISIS. That's where they both, as astronauts, practice the feeling of being weightless in both of those environments. But I'm not quite sure that doesn't mean that the acceleration of gravity doesn't have.
They are weightless on the vomit comet, and
yes,
what you're doing is you're being accelerated up, and then when you come down, you're trading back that acceleration, and it is for you are in a free fall. Hence, you're actually weightless.
Your body thinks you're in free fall. Well, you are.
You are in a free fall.
You are
relative to the Earth's gravity.
Anyway,
I'm proposing.
Lino is going to be last.
Yes, I'm proposing that rather than trying to debate with words, let's have a show of hands of people who want to join Carol and a bunch of other people, and go from words to just a thumbs up.
Well, you confirmed for me that the Ben Johnson videos are worthwhile. I've seen his series on several other topics, and I find him to be most enlightening. Tom, you're muted.
Yes. He walks the edge between too much and not enough information very well.
Specifically, there was the one he did on Quays, the company that produces the laser that can be used to do geothermal hole digging, not using bits, but using microwave.
Plasma.
That's a different topic.
There's a topic. Few hands.
Well, the whole thing about quantum computing and the coherence problem of breakdown and so forth, it's interesting that if there's two technologies and corporate interest in creating a higher quality control over quantum mechanics in the Bose-Einstein constant type product, I think that everybody's going to benefit from that. obviously from computation to GPS.
Or the failure of GPS. Chris.
My only comment is they said it measures acceleration.
Yeah. But knowing where you were and how you accelerated, you know where you are now.
Well, when you're driving down the Autobahn and you see, this is the joke about Porsche Turbo Carreras, when they're all together on the Autobahn, they're pretty much looking at each other for 600 to 700 miles, staring each other down. It's only the one that's got the faster acceleration that can get out of the pack. So, I mean, it's obvious that acceleration is just one vector or one magnitude beyond velocity. And then beyond that, you get a jerk and so on.
Still not perfectly clear to me. I will investigate this on my own. But still not perfectly clear to me how the measure of acceleration can result in knowledge of position.
Oh, it doesn't. You begin at a position and you accelerate.
So, yeah.
Then you know where you are. You were there, you did this acceleration, so you're here.
Acceleration is a vector, not a scalar quantity. So you know direction.
Okay.
It's a vector.
Yes.
But the magnitude of the vector.
Vectors have magnitude.
Right. The magnitude of the acceleration vector is not constant. It depends on the acceleration, and at constant velocity, the magnitude of the acceleration vector is 0. Now,
no.
And so I'm going to have to work on this. I'm not going to say anything more. I will investigate this on my own. It is not perfectly clear to me how acceleration, if it's constantly accelerating, then yes. But if it goes through a long period of 0 acceleration, then it's not clear to me that you can measure how far you've gone. And that is something I will have to investigate on my own, which I will do.
It's real easy. You know your speed at that point, and you just calculate for the amount of time that you're not experiencing. You experience the acceleration for a certain amount of time. That gives you a speed. Then in that certain direction at 0 acceleration, it just calculates how long you've traveled. And then when you de-accelerate, now it shows you at a stop on a point on the map.
Right. That could work. That could work, and maybe that's how they do it, but that hasn't been explained.
Let me try it this way. You are always accelerating, but you are unaware of those accelerations because your bottom is still tacked to the chair. You do not notice that the earth is spinning, but you are accelerating in that fashion, and you are accelerating downwards into the earth. And you're probably going to turn a little bit sideways over to the sun, and maybe even a little bit to zoom. You just are unaware of these accelerations.
But maybe the GPS system is unaware of them too.
No, GPS. GPS system knows about them and compensates for them.
I am done. I will explore this on my own. Not perfectly clear to me, but it's a very interesting subject.
I have succeeded in inspiring interest.
Let's
David.
Let's put
No,
it this
no,
way.
I am not. You have not expired interest. You have stimulated it, and I will pursue the interest on my own.
These devices indicate change in acceleration. Okay.
To repeat myself, it's complicated. You have to be aware of what your inertial change is, and you have to be aware of what the home system has done, and you have to figure out the difference, which is magic is a good word for it. It really is. To think you're going to figure this out in an hour, good luck.
Tom?
Yeah, I think the confusion is change in velocity versus change in acceleration. These devices indicate a change in the acceleration, and therefore you can figure out how you're moving with respect to your original position and your original acceleration.
Yeah.
And acceleration is the first derivative.
And they do that.
Velocity.
Yeah. And they do that using this Bose-Einstein condensate. If the atoms in the condensate get shifted a little bit, that can be detected because the light that's emitted has a slight shift, and that can tell you the change in acceleration and of course the direction.
Dean? Stan?
I was at a SIGGRAPH conference a few years ago, and they had a camera set up, and you had the monitor right there, and you stand in front of the camera and the monitor, and you don't see yourself because it's all gray until you move. And when you move, you showed up on the screen.
Mm-hmm.
And only when you moved did you show up on the screen, which was interesting because I think that was a process that was developed for cell phones. If the if the face on the screen didn't talk, they would just project the same pixels. It's kind of a compression technique for the pixels that were actually being transmitted were only in the areas where the pixel motion, where there was motion in the pixels. I'm only saying this because I think it's an interesting analogy about what's happening with. And is not the term for a change in acceleration called a jerk?
Yeah.
Okay. I just thought, I guess terminology is what I'm trying to.
That's what I think of it as.
Yeah, there's a fancier term for it.
And a change in jerk is a twitch.
It's a delta for accelerate. There's a delta in position, and then there's a delta in speed, and then a delta in acceleration, and a delta in the jerk as well. So
if you're in this context, you should be saying velocity instead of speed. Velocity,
yeah.
The vector, speed is the scalar.
Yeah, I'm sorry.
Okay. Carrie?
Okay. I think the issue here is I'm talking about relativity. General relativity deals with acceleration. Special relativity deals with steady states, right? They are two separate things, right? If you are, okay, a change in your inertial reference is acceleration, right? An accelerometer can measure 0. When it does, that means you are not accelerating, right? Constant motion equals at rest from your inertial framework. The reason we get confused is because the reason we feel the acceleration of gravity is because we're being held in place by the Earth. So we think that that's a steady position. We're not in relation to the gravitational center of the Earth. We're being accelerated. That's why in space, if you're in a rocket in deep space, right? If it is accelerating at 1G, it's going to feel just like you're standing on Earth. Right? As soon as you cut the engine on that rocket and stop accelerating, you are now weightless. You are once again in a free fall, and you are not experiencing acceleration independent of how fast you're moving. Right? This is why inertial navigation systems have to know the speed. Now, an aircraft, they just plugged in the airspeed, right? Which is different. And, you know, the other accelerations you're experiencing, we're on a globe, right? There's like Coriolis force. There's all kinds of stuff going on. I mean, that's why you have, you know, weather patterns spinning one way, you know, counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. So those are accelerations. In the same sense, when you shoot a cannon shot, you know, over the horizon, you need to calculate for this kind of stuff. But for all intents and purposes, if you're in a free fall, you are in a constant rate, hence no acceleration.
So you would have to measure the speed. How do you measure the speed?
Well, the acceleration will give you an idea of your speed relative to your initial starting point.
Assuming no friction.
Well, and see, the systems that the airliners use, you would constantly have to reset these things in the same way that I can close my eyes and I can navigate across my room, but I can't necessarily do it all the way down to the block, right? And a blind person, that's why they've got the cane, right? They're constantly checking and rechecking, right? And that's the issue with the submarine, because you don't want this thing constantly rechecking where it's at, because there will be, now, if you have a frictionless system, it's going to be better. But there's going to be things like currents in the ocean that are going to impart different motions to you. I mean, it does get complicated.
Very quickly.
Anyway.
It gets very complicated. The idea, the first lie is that the Earth is a sphere.
Well, it's a creative simplification. It's not a lie. Lie implies something else.
Okay. But it's, as we've learned more and more about the Earth, we have learned that it is
an oblate spheroid.
I'm sorry?
An oblate spheroid.
Well,
something like that.
Very roughly. It has, well, first it has all this water on it, which goes up and down.
And around.
Then there are mountains and seams of minerals, which are heavier than the neighboring places. And there are holes, both natural and man-made. Man-made, they're usually called tunnels, but they're not always. But some of these things can be detected now. And it's part of all this confusion is talking about it in words instead of math. All of the hands have gone away.
No. Not
No.
quite.
Okay, David. I'm sorry, David.
One thing that's fairly clear about this is that there are common usages for knowing better where you are, and there are advantages conferred by the use of technologies that allow us to determine those with some degree of precision.
Mm-hmm.
Now, clearly, an inertial magic box would get around some of the difficulties with our current GPS system.
Yes.
He referred indirectly to the current cost to do that. High. Potentially it may come down if they're successful and if they can continue to get funding. It's always going to be an expensive proposition from everything that I can see.
Good afternoon to everybody.
Yeah, it is going to begin by being very expensive and very fragile. But now, your GPS used to take 2 40-foot semis of equipment and 6 exterior antennas on the roofs of those, 3 on each. Now I fit it by shirt pocket and lose it. And there are even, I have seen prototypes of a ring that was a GPS thing. It just had a little display, and all it showed was the digits of your location. And yeah, you can do. Okay, so you got the ring and you've got a map, and so you're okay. Okay, this is probably too much shrinking of the useful device.
Right.
But if there was a way you could implant it and have a display on your contact lens, I can see how, but I can also see how it could be hacked. If we start the second video, we're going to go over. Tom?
I was just saying that obtaining and maintaining system in a Bose-Einstein condensate is not easy.
No.
Currently, it takes some expensive lasers and a large box and that kind of stuff and containment system. So a pocket version, I think, is currently beyond our technology, but we could get there in maybe even the next couple of decades or less. But I'm not sure that's practical. If you have it in your pocket jiggling around, that's pretty, that makes it kind of questionable whether it can keep track of all the little accelerations versus the ones you're really interested in. So
yeah,
it would have to be attached to someplace in your car that's fairly stationary, except when the car is moving, rather than on your person, especially in a wristwatch. I don't know if that would be practical at all.
Yeah, the first time I saw an aircraft inertial system, it was the size of a big SUV.
And it worked on gyroscopes?
It worked on actual 6 spinning Sperry gyroscopes. I don't remember how much it was. It was some astronomical cost, and it basically took up 1/3 of the volume of the DC-3 it was put in. Cheapest thing they could find that would fit in. But it worked. And 5 years later, it was the size of a bug. And now it's the size of a big book. Although
You meant
that's
Volkswagen
not using
bug.
actual, that's
Yeah,
not used
Volkswagen bug.
Yeah.
Volkswagen bug. I think the smallest the actual gyroscope ones ever got to be was probably like the size of a dishwasher for mechanical gyros. Then they changed to what are called ring laser gyros, which is where you have a laser that's split and bounces around a triangle or a square, depending on which design it was. And you measured the difference in the path lengths. And then someone got the bright idea that instead of having to deal with this thing, we will just take and send the light down to a long spool, a kilometer of fiber optic cable, which could be coiled up, and it became even smaller. And this is just, it's going to get smaller and smaller and smaller and smaller. There is certainly going to be an end to the smallness eventually, but I can easily imagine that the size of a, let's find a handy book. I can imagine an inertial reference unit being this size. Probably not in my lifetime. But in 20 or 30 years, yeah, I can see that. And I can see bad actors thinking of ways to attack that box. So that either the easy thing to do is to kill it so it doesn't work. That's much easier. But I can see people trying to figure out ways to make it lie. How you would do inertial spoofing, I can't imagine. But then I couldn't imagine GPS spoofing either. But it's a real thing. Oh, if you use GPS out in the big bad world, you should have a thing on your phone called anti-spoof, which is a thing that looks at your phone's GPS reception to see if some of it is fishy.
Is that a pricey software?
That's a free software.
Okay. GPS spoof?
Anti-spoof.
Okay.
It was written by a guy who teaches celestial navigation.
David, you're up.
And David.
Clearly, technology is advancing, will continue to advance, but cost is a factor. If we could do ring laser inertial navigation,
yeah,
and make it work most of the time, it's probably going to be less expensive than Bose-Einstein condensate measurements
for a long time.
For the next 20 years.
And smaller.
10 years. But it seems like if we could figure out how to deal with bad actors, we could continue to use the GPS system that most of us depend on.
Mm-hmm.
In most cases, just fine.
it's there are problems from a water navigator's viewpoint. There are problems with GPS. It's not sufficiently accurate always.
Uh-huh.
I mean, I can dig out my sextant and go out and take sites, and I can find out where I am on the planet to within 3 miles. I'm not very good. Which is fine for getting across the ocean. If I get to within 3 miles of the west of either coast, I can see the shore. Landfall. Other places are trickier. If you're trying to sail between some of the islands of the Tahiti group, as the tide goes up and down, there are needle-like rocks sticking up from the bottom. And the paths between them are sometimes only a couple of 100 feet wide. So accuracy to a kilometer or to 100 meters doesn't cut it. You put somebody up on the top of the mast or near the top and you have them looking down because it's that tricky. Inertial might make that better, but you're going to have to go out and measure all of those needles, and then they're going to move. And of course, the water keeps going up and down. So it's part of the joys of navigation is that it's a perennial problem. I mean, it's all very well and good for Ian Banks to have people navigating between universes, but we're still struggling to get around on our own planet. Ring laser gyro inertial systems are now the size of a washing machine, maybe a little smaller. But
and what cost?
I'll guess $1 million, but they're almost a production item. You can go to a number of companies and buy them. The expensive part might be integrating them into the cockpit avionics, not just the box itself. Box would give you a digital readout of your location, but the pilot doesn't want that. The pilot can't use that. He needs the information integrated into some of the modern displays. But it's an old problem, and we're finding better and better solutions to it. But yeah, Tom,
you have the second video you have listed on the meetup site is 50 minutes long. Is there any information in there that we haven't covered already that might be useful to see part of it?
I have that queued up, Tom, if you want me to start it, but maybe you want me to start it somewhere in the middle or towards the end or something like that?
I would rather people just grab the address and watched it at home, so to speak.
Sure.
There are good bits and slow bits and good bits and slow bits, but trying to, since I did not take notes as to that, probably the first, I only try like the first 5 or 10 minutes, which is kind of an introduction to the problem. And then the physics starts and it gets kind of whiskery.
All right, I'm going to stop recording.
Mind-numbing detail at times once they get past the history of it.
Well, I think we saw a good reason just by watching the beginning first for seeing it out. It's a good video.
Okay.
No, at home, seeing it out at home, I say.
Yeah. Chris,
where are the video locations posted?
on Meetup.
The idea of a gravitational map is intriguing. It could be monitored. If the features were different enough, it could be monitored by a computer. And if the resolution was good enough, probably every position on the Earth has a slightly different gravitational field. And it would be, if you could visualize, if you could make like a topographical map of the gravitational field of the Earth that couldn't be seen by a human being, but could be seen by a computer, I would think that in itself would be adequate for navigating. Intriguing idea.
It could be used for some navigating, but it could be used for, oh, good heavens. You could use it to detect someone digging a tunnel under your border. Or where there's a void in the earth, an unknown cave that was closed off by a rockfall centuries ago.
On a routine flight between Helsinki
I would think
where's a good place to dig for X?
See, I think it could give a unique surface to the Earth because it could detect the magna layer. Difference in that, it could detect the core, which is not uniform, and it may give a unique value, or at least a unique topography for every position on the Earth, because the gravitational field of a sample on the Earth is a composite of the composition of the Earth all the way down to the Earth's core.
Yeah, but it's also it's not straight down, it's also attraction to things 1,000 miles away.
Right.
So the idea that you've got a single value that you can use as a map reference doesn't really work.
That sounds about right. That sounds
but
right.
The change as you drive along the road and you see it going up and down. We're looking at like the 10th, 11th, and 12th digits of the value over here. Right. There's something not under us. There's a hole there.
It would even work on the ocean.
Yeah. The bottom of the ocean is at least as up and down as just driving across not across the plains, but across like down the mountains. There are all sorts of mountains and lumps down there. probably half of the lost submarines in the last 50 years have been from submarines running into mountains that they didn't know were there. We found some of them.
Tom.
But also in input.
Tom, you're muted.
Tom, you're muted. Mr. Walsh, you're muted. You're still muted.
My guess is
There you go.
I'm not sure how that happened. I just want to let you know that I just posted in chat the fact that we do have gravitational maps of the Earth, created by both NASA and the European Space Agency satellites, and they're pretty accurate. I'm sure they can be improved, but we do have good information on that already.
David.
Yeah, I'm still intrigued by the idea of world problems that need to be addressed at a world level. And what are we going to do in the future about economically integrating the world and implementing a rule-based system fairly across the world? Because clearly bad actors are causing economic consequences for the rest of the world.
I think the problem is that what one nation or societal group or corporate group or whatever might see as fair, others would not see as fair. It's not easy. I mean, look at what Russia's doing. Russia's a bad actor on many fronts, and this is one of them. If they keep disrupting the GPS of jet airline flights, they could cause a crash. So, and they don't seem to care.
On a routine flight between Helsinki and Tartu, a pilot glanced at his navigation instruments and...
So yes, this is a big problem, but I don't see a solution. The United Nations is not strong enough to implement something like that.
And the United States thinks of themselves as being first among equals, or needing to be the premier country in the world. We want to run things, which of course is not fair. But there are so many different arenas in which the world would like us to pay more attention to other opinions than our own.
The average person sees around...
At any rate, seems like there's quite a number of possible discussions about the future that this particular technological issue ties into.
Well, I've heard a lot of discussion when it comes to, say, for example, American currency and fiat currencies and so forth, and the rise of the BRIC, the Brazil and Russia and India and so forth. The idea that people are going, the argument I've heard amongst some people is that if there is a choice between the dollar and these other currencies, because of the background inertia, reputation of the dollar and the American way of doing things, as well as knowing that it's not always the best, but has a reputation for maintaining a certain level of quality and assurance. That's kind of what I'm hearing being talked about. And it'd be nice if we could somehow keep that polished stone glimmering, if possible.
That could change the next 4 years.
I was going to say that, but I kind of restraining myself. We went through a 4-year period of that same phenomenon, and we survived somehow. But I don't know.
Well, the
it seems like
question with currencies is what are you using them for, and what are the alternatives? There's a book called Easy Money that I'd like to recommend again for anyone considering digital currencies. They don't have a very good track record up to this point as being stable, as being a reasonable container of value. The United States has a problem with the national debt. Politically, it's not at all clear that there's any possible solution to the national debt at this point. That makes the dollar as a store of value of significant questionable value over the long term, over a 20-year period. Now, what else is available that's any better? Well, any of the digital currencies have so much fluctuation that it's as much of a crapshoot as the stock market.